Okay, we did not think this was gonna happen, but it is. We got permission from our State Department to fly out, and we also got permission, authorization from Egypt's civil aviation to be able to fly in to Cairo. So we are on our way to the airport right now to catch our flight. It leaves in a few hours. But we were just notified last night, so we had to pack real quick and get our things together. I will check back with you guys when we get there on one of our tours of the pyramids. And hey, is everybody buckled?
Yeah.
Okay, so we are ready to roll, and I will check back with you guys later. I am ready to walk like an Egyptian. Okay, this is a pyramid, and in particular, this is a rectangular-based pyramid or a square-based pyramid. Squares can also be classified as rectangles, so we are just going to use the term rectangular-based pyramid for this example. Now, this pyramid has 5 sides. Each side is called a face, so it has 5 faces. One of those faces is called a base. This is the base of a pyramid. That's why it's called a rectangular base pyramid. Now the other end, the opposite end of the base, is the apex, or the vertex up here. All the faces along the side or lateral part of the pyramid are all triangles. Now there are some identifiers that we need to look at. One of them is the slant height. The slant height, similar to a cone, is the height along the face from the apex to the base. Straight down the center of the face, forming a right angle with the base. This would be where you would find the slant height. Now, it has another type of height as well as the cone did. The height is found from the apex straight down to the base, so that it forms a 90-degree or perpendicular angle with the base. So here I've used this rod to show that it goes straight through the center of the base all the way up to the apex. That is representing the height of a pyramid. This is representing the slant height of a pyramid, similar to a cone. Two other things that you need to know are the perimeter of the base. The perimeter of the base is just simply the distance around the base or the bottom of the pyramid. So you're just going to calculate the distance of each side. The other one is the area of the base, represented by the uppercase B. The area of the base is all of this here. So we have the slant height, the height straight from the top to the bottom. We have the perimeter around the outside of the base, and then we have the area of the base. Those are the things that you're going to need in order to calculate the surface area and the volume of a pyramid, and in this case, a rectangular base pyramid. In order to find the surface area of a pyramid, and in this case, a rectangular base pyramid, you're going to need to know the value of 3 different variables. Those 3 variables are an L, which stands for slant height, a P, which stands for perimeter, and an uppercase B, which I call the queen B, and I'll explain that in a few minutes. And that stands for the area of the base. Now we'll start with the L. The L represents the slant height. So the distance from the apex straight down perpendicular to the base of the pyramid. The P stands for perimeter, which is the distance around the base, only the base, the distance around the pyramid along the base. And your final one, I call the queen B because it's represented with an uppercase B, which means you have to try to find the area of the base, which is the length times the width. To find the volume of a rectangular base pyramid, you're going to need to know 2 variables, or values of 2 variables, and those would be the queen B and the H, height. The queen bee, again, is the area of the base. The H represents the height. The height is the distance from the apex straight down through the center of the pyramid to the base, which is different than the slant height. The slant height was along the surface of the outside of the pyramid, along the face. The height of a pyramid is from the apex straight down, vertically perpendicular to the base of the pyramid. The formula to find the surface area of a rectangular base pyramid is 1/2 LP plus B. The formula for the volume of a square or a rectangular base pyramid is 1/3 BH. Did I just say a bad word? Hey guys, I'm just doing a check-in right now. So far it's been a fantastic expedition. It's, other than being extremely hot, windy, and sandy. In fact, there's so much sand here that I had an actual sandwich when we stopped for lunch. Go figure. But anyway, our goal is to get here down the bottom of this giant sand dune to this pyramid, and we get to check that out. Our tour guide said it's going to take about another half an hour to get there. So I kind of question that, as slow as these camels move. I mean, but it is a descent. We're going downhill, so maybe. We'll see. What? Okay, well, I'm told it's time to move out. The tour guide is already started, so I've got to go. I'll check in later. Calculate the surface area of this pyramid. We're going to need the slant height, which is from the apex down the outside of the surface of the face and perpendicular to the base, which is 126 feet. Next, we're going to calculate the perimeter, which is the distance around the base. If each side is 80 feet, then we can just simply do 80 times 4, which is 320 feet. The last value we need is the area of the base, represented by the large uppercase B. All we need to do is 80 times 80, length times width, or 80 squared. So the area for the base of this pyramid is 6,400 feet. Now we're ready to calculate. Plug in the values we obtained from our measurements and simplify. There are a total of 26,560 square feet on this pyramid. To calculate the volume of this pyramid, we're going to need to know the area of the base, which we have already determined is 6,400 because we did length times the width. The last measurement we need in order to help calculate the volume is the height of the pyramid, which is the distance from the apex straight down inside the pyramid to the base at the bottom, which is 120 feet. We are now ready to find the volume of this pyramid. We're going to plug in the values that we obtained from our measurements, and then we're going to simplify. So using our calculators, we would plug in 1 divided by 3 times 6,400 times 120. This pyramid has 256,000 cubic feet. This has been a fantastic getaway. I wish you guys actually could have been here, but I'm glad you were able to participate with me this much. And maybe next time it'll be even more fun. What I'm going to do is when we get back to the States, I'm going to throw together some practice problems for you to practice calculate the surface area volume of miscellaneous pyramids, and then a few challenge questions here and there, maybe determining the slant height, or perimeter, something of that nature of a given pyramid. But anyway, it is we need to hurry up. We need to hurry up and get going and catch our flight back to the States. And it has been amazing. I hope you guys get a chance to come here one day. It's hot, but it's nice. We really enjoyed it, and I am on my way back to America.